Alright, so today we're going to be picking up in 4.3, where we're going to be working with logarithms more and some of the properties. We know what a logarithm is, basically. It's a rewrite of an exponential. And that log button is just really a powerful button on the calculator. But we can't always go straight to the calculator. Sometimes there's variables and things, but we want to be able to rewrite and maybe get some of the logarithms out of the problem or look at different ways to do it. And so we have what's called the product rule. This works for expanding and contracting, but the product rule says that if there's ever a multiplication inside of the parentheses of a logarithm, that we can separate it into two logarithms with an addition between. Meaning that because I have 25 times x right here, this can be written as, sorry about that. And so what we're going to do is we're going to expand this logarithm because the multiplication occurs. So we're going to write log base 5 of 25 plus log base 5 of x. See, we separate the multiplication into two addition problems, each having its own logarithm. And what's really neat here, and is the purpose of all of this, is that this is something I can evaluate. Turns out log base 5 of 25. Well, what exponent do you put on 5 to get 25? The answer is 2. So this is 2 plus log base 5 of x. This is a much more solvable equation. You know, if this was equal to 10 or something, I could subtract the 2 and then I could work on it. The original problem would have been a little bit more tough to work with. The second rule is called the quotient rule, and product is multiply, quotient is divide. So just like multiplication and division are opposites, when we're dividing, instead of adding, we subtract. Same rule. In fact, everything that's negative is going to go to the denominator, or come from the denominator. So this would be log base 3 of y, and because 27 is in the denominator, I would do minus log base 3 of 27. Well, 3 to the third power is 27, so this is really 3. So I now have log base 3 of y minus 3. A much simpler looking equation when I've gone through those steps. So product, if you've got multiplication, it becomes addition. If you've got division, it becomes subtraction. And what's really cool is this actually goes in reverse. Let's say that I had log base 3 of x plus log base 3 of y. Then this is log base 3 of xy. Because addition meant that they could be multiplied, multiplication means that they could be addition. So there's that back and forth here. The third rule is what we call the power rule, which says that if you have an exponent, so imagine this p is actually up here, an exponent on top of something in the log, that exponent can come out in front and sit in front as a multiplier. So this example, we'd have log base 3 of 9, and instead of doing the square here, I'm going to bring the 2 out in front. Well, log base 3 of 9, 3 to the second power is 9, which makes this 2 times 2, which makes it 4. So this is solvable, and it becomes a little bit easier by pulling the 2 out in front of the logarithm. Now the same thing can happen here in this natural log. ln, remember, is just a different type of log. But I'm going to write this as ln of x to the 1/2, because the square root is a 1/2 exponent. And we know from our rule that we've just looked at, we can pull the exponent out, making this 1/2 of ln of x. And that's a simpler looking problem, because now I'm down to just the ln of x. The square root's out of the problem. It makes it a lot easier to work with. The last property that we really need to focus on is what's called the change of base. And this is, you know, our calculator traditionally operates in log base 10. That's the log button, okay? Or ln, which is log base e. Those are our two logs that our calculator traditionally can handle. Well, for us, we want to be able to use different logs or different, we want to be able to use the calculator, but we can't because sometimes the log is not the right base. So the way we do it is you can almost draw a division line in, and m, it's on the top half, b is on the bottom half. So if you just kind of draw a division bar in like this, 23 will go on top, 5 will go on bottom. Both of them get their log. So log of 23 over log of 5. Now these are both base 10 now, so they can both use the calculator, and that becomes an easier problem to solve. Okay. Over here, we could also do the same thing with ln. If you don't like using base 10 logs, you can use ln, and it does the exact same thing. If we did a little division, 30 is on top, 6 is on bottom, making this ln of 30 over ln of 6. Now, I'm going to show you how to do it in the calculator two ways. Okay. So first thing I want to look at is log of 23 over, divided by log 5. Now notice I used the parentheses there to close them off like that. I get this value. Let's say I had chosen to do the natural log of 23 divided by the natural log of 5. I end up with the exact same number. So it doesn't matter which one we're using. We're going to use one of the buttons to split it that way. Now, there is an option built into the newer calculators to do this log a little bit differently. If I go into the math and I go down far enough, I will see option A. It says log base, meaning that it can edit the base. And here I get that subscript option, so I'm going to put 5 there and 23 here. Now, some of you will prefer to do this. I don't think that there's anything wrong with doing the change of base formula, but you can do either one. All three versions give me the exact same thing. The only issue with this log formula is you have to either go get it every time, or you have to feel comfortable coming back up and then re-editing that information. Okay, so just be comfortable with that. All these rules and things like that are on page 401 and 402, and that should be enough to help you out. So good luck, and we'll see you in class. Thanks.